Hello everyone, and welcome to today's video by OKM3D. My name is Sven, and today I want to tell you a little bit about these Anisoprint printers that I have here next to me. This one is the Desktop Composer A4, and this one is its bigger brother, the Desktop Composer A3. Both of them are pretty similar. Their main difference is their build volume. As the name says, the build area of the build plate on this one has about the size of an A4 sheet of paper. On this one, it is approximately an A3 sheet of paper, plus a little bit extra on all sides for dead space and, moving around. So that's the basic naming part of these printers, and the rest of their features are practically identical. This one's just a bit bigger. But what are these features? What are these printers even good for? They are for printing plastic parts reinforced with continuous fibers. So not short and chopped fibers as you can already have. You can go out and buy a PA12 reinforced with carbon or glass fibers or something like that. No, instead, these printers are for reinforcing your parts with continuous fibers. And there's two different fibers you can buy from Anisoprint, either a carbon fiber or a basalt fiber. And you can choose which one of these to put into your part. The carbon fiber is stronger and stiffer, but more expensive. The basalt fiber is cheaper, but not as strong and a bit more flexible. On top of that, carbon fiber is conductive, and basalt fiber is very insulating. So if you're looking for thermal or electrical insulation, then basalt might be the better option. Now, these printers can put the continuous fiber into your parts within the 2D plane. So no fibers across the different layers, because in the end, this is still FFF printing technology and limited by all the same problems that FFF technology itself has. Now, the way that Anisoprint achieved this fiber layup into the parts is by designing a special printhead, and this printhead has sort of two halves. On the left side, there is a standard nozzle that prints only plastic. So it's like any other FFF 3D printer with a plastic nozzle. But on the right side, that's the special one, because that's the one that combines the continuous fiber and another thermoplastic together in the hot end, and then they come out of the nozzle together as what Anisoprint call a bi-matrix composite, because the fiber is pre-impregnated, and then you add that other thermoplastic, so you've got two different matrix materials around the fiber, and that's why it is a bi-matrix composite coming out of that nozzle and then reinforcing your part. Now, the basic rule when thinking about how to reinforce your part with continuous fibers is always reinforce the surface area first, because any part is first stressed on its surface. And you can see that in this lever that we have here. The fibers first go around the surface area. They reinforce the outer walls. And that already makes this part so strong that I cannot possibly try and break it. No matter what I do, I'm just not strong enough. So that's the first step. Always reinforce the outside of your part. But then there are some cases where that is not good enough. And that's where Anisoprint has the big advantage. Because Anisoprint not only enables you to do the outside of your part, it also allows you to draw custom trajectories on the inside of your part with those fibers. So very specific load cases can then be reinforced exactly as they have to be in order to make your part the strongest it can possibly be. And if that is not enough, you can then also add lattice structures on the inside of your part. Also something that nobody else can do. You can actually print these grids out of the continuous fibers on the inside of your part, and there are a couple different patterns for different applications. Generally, this one is the best. So that's the brief introduction to what these printers can do. Now, there are three basic packages for these printers. You can either have a very locked down and closed version, a sort of middle ground, or a completely open system, and it all depends on what you want. With the lockdown version, you're only able to use the proprietary materials by Anisoprint, which is a fiber-reinforced PA12 nylon for the left nozzle, a natural PA12 nylon for the right nozzle, along with either that basalt or carbon fiber. Alternatively, you can use a clear PETG for both the left and the right nozzles. So that's option 1. Option 2 is you get the Ext pack, with which you get an extended warranty, you get more settings available to you in the slicing software, and you get to use a number of partner materials. Still just the carbon and basalt fibers though. Or you then go for the open pack, which is the fully open version, where you have access to absolutely all of the slicing settings that are possibly available, and you can create profiles for any plastic and any fiber that you want. There are customers that are using these printers to print copper wire into their parts as a substitute for the carbon fiber. The only requirements are in terms of diameter. It has to fit through the nozzle. If it is a fiber, it has to be pre-impregnated so it doesn't fray and go everywhere. And it has to be adhering to a certain corridor of stiffness. So if it's too stiff, it cannot come out of the nozzle properly. So those are your 3 requirements in order to print a different fiber. And for a different plastic, well, the print heads go up to 270 degrees. Anything that can melt, you can print. So we went ahead and just made it with TPU. So we printed a part that combined TPU and the continuous fiber, and the fiber reinforces only the left half or one half of this part. The other one remains as TPU. And then that remaining half is nice and flexible while the other half remains stiff. So this is a way you can stiffen and reinforce selected areas of your TPU parts if necessary. So that's also something you can do with this printer that is very special about them. And yeah, it's actually fairly easy to do because the slicing software is very intuitive. And as I said, you have these options of going for the closed version where you have very little options, but it's more of a plug-and-play experience, or you can go for the open version where absolutely everything is available to you and you can just play with it to your heart's content and adjust everything until you're satisfied with the result. The printers themselves are set up fairly simply. This print head is very, I don't want to call it basic because it actually does all the magic of combining this fiber and plastic into your part, but the makeup itself is fairly simple, meaning there's not too much that can go wrong, and if something does break, it's very easy to replace it. The navigation of the printer interface is also fairly simple. There's only a small touch display that you can then use to navigate through all the different menus, start the print, do the calibration, etc., etc. So yeah, I think that's the basic overview of what these machines do, what they're good for, and how to use them. And I hope I answered any questions you might have had. I'll still show some more close-up images of parts that I printed and some of the printer parts that are relevant for this, the print head, the built plate, the display, etc., etc. So if you're interested, stick around for that. Other than that, thank you very much for watching. If you do have any further questions or comments, please leave them below. And I hope to see you again in the next video if you did like this one. So see you then, and have a great day.